Our fourth lesson in chapter 4 is the multiplication rule. This is dealing with when we have to deal with and in probability situations. And again, as we just said, we use the multiplication rule when we are dealing with the word and, multiple probabilities, multiple events. Finding the probability of event A, then B occurring will mean to first find the probability of event A occurring on the first trial and event B occurring on the second trial. Since we have this rule, therefore one could assume that the probability of event A times the probability of event B would be equal to the probability of event A then B. But there are other things that we have to consider before actually applying that rule. We have to discuss independent versus dependent events. We have to figure out whether the simple events are independent or dependent of one another. This obviously means that we're going to be dealing with possible replacement and not replacement. In this case of an independent event, when we're rolling a die and drawing a card, those are independent events because the effect of one is not going to affect the other. Dependent events, however, would be when when one will affect the other. For example, drawing two cards at the same time or drawing cards without replacement. Your sample space gets smaller the second time you draw because you have one less card in the deck. We have a formal multiplication rule that we can use. Notice the symbol for given that. It's in pretty much a straight up line going vertically. The probability of event A and B is equal to the probability of event A times the probability of event B given that A has occurred. The probability of event B given that A occurred is equal to the probability of B when events are independent of each other. Again, if these rules are getting a little confusing for you, we do have the intuitive way of doing stuff momentarily. Now, a very special guideline of independence, and we'll deal with this as we move forward with probability distributions. If we have a sample size that is no more than 5% of the population size, you are allowed to treat those selections as if they are independent, regardless of if the events are independent or dependent. The reason for that is because, in essence, your sample size is very, very small compared to what the population would be. So we're allowed to treat those as if they were independent events. Here's an independent example. We have a standard deck of cards. The first card will be replaced after it's selected. Let's find the probability that two kings are drawn in succession. The probability of the first king would be 4 out of 52. We put the card back, and the probability of another king would then be 4 out of 52. We multiply the two together to get our actual probability, two kings in a row, which is 16 out of 2,704. You are welcome to leave that in fractional form or decimal form. Here's a dependent example. We're going to do the same type of test, except this time we will not replace the cards. This actually explains why the New York State Lottery does what it does in terms of the win 4 and pick 3 numbers. They allow repetition. The probability of the first king stays the same at 4 out of 52. There are 3 kings now left in the deck with 51 cards. That makes the probability 3 out of 51 for that second king. Multiplying those two particular fractions, we now have 12 out of 2,652. And even though it's very minuscule, you have actually increased your odds. Your homework in this section is textbook pages 168 to 169, numbers 2 to 26.